All right, welcome to Crrow777 Radio Podcast. This will serve as episode 14, and though I have said in the clip it will be 13, I explained in my last episode why things got out of whack there. In this episode with Brian Mullin, we cover a lot of interesting things, and I think the real value of Brian Mullin is that he is a very well-trained engineer, and he's bringing the science and math that he learned in higher education to challenge the things that we have been told, even to go so far as in part of this interview, he says, you know, the scientists are the smart guys and we're supposed to take their word for it. But that time is over because we're going to challenge all that now. And I think it's critically important for these guys who are very well educated to come on with what they can bring, because so many people out there will not accept what people like me are going to say, having just used observation, deductive reasoning, and the decoding of our language, movies, and memes. That's not enough for them. So having someone scientific using high-level math coming at this is a real boon in my view. Anyhow, we've had quite a week, and I wanted to mention the whole Juno thing going to Jupiter. It's just more encoding. I saw a number of people like Zachary Hubbard covering it. Others, I saw the Jungle Surfer covering it. I don't remember if it was Spudgy Pang. I think even Spudgy Pang may have covered it. I hope I didn't get that wrong. These are all people that I keep an eye on. Jungle Surfer recently did a very good clip on the JFK assassination, just throwing down some common sense and observation that demonstrates that you're looking at fraud. Again, Spudgy Pang is out there doing the whole Seattle prediction, and I think it's got legs. I'm watching with bated breath to see if this gentleman is going to be able to predict a false flag in a meaningful way. And Zachary Hubbard, as usual, is at it, just cracking the numbers down. But what got me on this little spiel is that Zachary Hubbard had covered something that I noticed right out of the gate when Google did the Google Doodle that covered the Juno spacecraft. For those who saw it, it was instantly visible that the word goy was encoded in that little doodle. We had the typical G-O out of Google, and then a little representation of the spacecraft making the Y. For those of you not familiar, you can go online, look up what goy is. It's basically a derisive word for everyone who's not Jewish. And there is much more in-depth versions of definition for that word. But I think that's a very telling thing. Even if you take the wordplay in the word Juno spacecraft, you could begin to say, and I'm not kidding here, goys don't know, but Jews know. Juno spacecraft. And people will laugh, but this is exactly the kind of wordplay that we see in these things. When you begin to take a construct like this apart, where you are being derisively termed a goy in a public way, well, actually in a worldwide way, because that Google Doodle goes everywhere. And you begin to consider that if you were to look at the percentage of Jewishness on this world, what the heck is going on? In the last episode, I covered that Jewishness has provided marks on all the food we eat. So here in the United States, whatever it is, 6% of us are Jewish, and yet nearly 100% of the food has kosher marks on it, presumably blessed by a rabbi. What is going on here? Part of the problem in talking about this is we have been conditioned that we're not allowed to talk about black people and say the word nigger because that's derisive. And if you're white, you can't even use that word. Well, I don't follow that construct because I don't feel any differently about black people than I feel about any people. So to use the N-word, as it is now referred to, will probably never leave my lips, except that it just did, to show that it's just a word and intent is everything. And yet, when we pull this back around to Jewishness, which we see so blatantly thrown in our faces, we have to face the charge of being anti-Semitic. And at some point, this has to be cast aside. At some point, we have to honestly assess what it is to be Jewish and what it is to confront places like Hollywood, which were 100% owned and operated and 100% encoding false flag attacks, putting their marks on our food, blessing it with a religion most of us don't follow. How do you stand up against this in this modern construct that has been put in front of us where if I even start to talk about Jewishness, I'm likely going to be termed an anti-Semite, which is not the case. I have many friends which are Jewish, and that's not the Jewishness we're talking about. We're talking about the upper reaches of Jewishness, and I don't even think it has anything to do with genetics. I am a person who subscribes to the idea that the word Jew was originally a level of initiation, as was the word Christian, as was the word Hebrew, as was the word Israelite. Levels of initiation, and Jewishness was one of the lower initiations. When you started to get up into Israelite and Hebrew, you were above the Royal Arch degrees in Freemasonry, who share nothing different from the mystery schools that have been going on all the way back to a supposed time when there were ancient Greeks, if there was such a time. Now, this is a bit funny, a topic to bring up when Brian Mullin's about to come on, because Brian doesn't cover any of this, and to be honest, he's simply demonstrating that science can be used to demonstrate that most of what we have been told about space and our world is a lie. It's a fraud. But I am appending to the beginning of this show that it is pretty obvious and clear that a initiation level called Jewishness, which has nothing to do with genetics, has everything to do with a religion and a group of people who seem to have taken over most of the key aspects of our society, from banking to entertainment to Lord knows how far this goes. And at some point, we're going to have to question it, because everything that Brian and I go at here today, at the very foundations of what we're talking about, is lies. Lies that were put in place by those who had control. Lies who were put in place by those who had all the money, all the power, and it's just as simple as that. To be honest with you, I don't know if I'm going to run this intro. I may or may not. I'll listen to it back and I'll think about it, because the problem becomes this. When we become to address this, people think that I am being the anti-Semite I will be charged with. And again, I say I'm not. I have plenty of friends who are Jewish. They have nothing to do with what we're talking about. But there is no separating the fact that Jewishness does reside in the encoding of our food, in the blessing of our food, in the owner and operatorship of all entertainment that comes out of Hollywood, in our banking system, all the way back to the Rothschilds, which is a Jewish organization at its pinnacle. So I'll listen to this back and we'll see where this goes, whether I run it or record it. But let's get Brian Mullin in here. It's a fascinating show to see a man of science bring his higher education to bear on the lies and foundational untruths we have been told throughout our lifetime. So let's jump in. Okay, so I've listened to this back and I'm going to run it. I've just used a simple measure stick as I listen to this. Intent is everything. If you intend to be deceptive or cruel or anti-Semitic, that's intent, and that means something. There is no intent to be anti-Semitic or anything else here, but I am in fact pointing out a problem, a huge problem. All this false news, 9/11, all these things have been encoded by a people who run our entertainment. And maybe it would be more accurate to call them Zionists than it would to call them anything else. But in the second hour, we are going to be running so many things we cover, and it's all Brian making comments on the constructs that we've been handed about our world and space. But one of the most astounding things that we cover in the second hour is Brian is working to create an actual monument that spans some miles that will prove one way or the other whether the curvature we have been told is on our world is there. And not only will it serve to demonstrate whether or not the curvature is there, it will stand as a monument henceforth after it is done. So without any further ado, let's jump in. All right, welcome to Crrow777 Radio Podcast. This will be episode 13 with Brian Mullin, who is a mechanical engineer. I've been trying to hook up to do this show with Brian for a while, but he's going through some pretty significant life changes. So welcome aboard, Brian.
Thanks, Crrow. I'm actually a structural engineer, but everybody thinks I'm a mechanical engineer, but it's an ethic. But yeah, thanks. Good to be here.
My bad. I think I must have assumed that. Anyhow, I think congratulations are in order. You found a life partner recently.
Yes, I did. We're getting married here soon in a few days, and yeah, things have changed a lot for me, but it's been great.
It's pretty funny. I think a lot of people that followed you saw the video you put up when you met this gal.
Mm-hmm. Yep. Yeah. I showed it to her, and she told me I could post it, so I had to do it.
Perfect. So are you actually moving as a result of this, or?
Yes, I am. Yep. I've been trying to move, and I've learned the process of getting married and everything, so it's been a learning experience. I never thought I'd actually be in this situation, to be honest. So it's been a lot of fun, though.
Well, it's a good thing. It's a good thing. But anyhow, I know we're both a bit pressed for time, and that we've been trying to get this this discussion recorded for quite a while now. I started asking you if you'd come on the show right before you met your fiancée. So let's go ahead and jump right in. I know we kind of outlined a broad list of topics that you'd like to cover. Primarily, though we may get in some other things. So without anything further, let's go ahead and jump straight into Virgin Galactic, satellites, ISS, and GPS. Do you want to take these one at a time, or where would you like to start?
Yeah, this is definitely I think the starting point when you really start to question what our world is. Virgin Galactic, in 1999, I think we just start with them and go through the satellites and everything. But in 1999, Sir Richard Branson announced to the world his company, Virgin Galactic, and said by 2007 that we would have commercial flights available to the general public, tickets available for purchase, and you'd be able to take a flight into low Earth orbit and experience weightlessness, look down on Earth, look out into space, and all that fun stuff that these astronauts get to do, allegedly. And that never happened. And they've actually never been able to achieve low Earth orbit. None of their spacecraft have ever made it into low Earth orbit, which is, when you really think about it, in 1999 we had the internet, we had all of these experienced aerospace engineers, all of this experience out there to help Virgin Galactic achieve this, and they've never been able to do it. And then in the 50s, the Russians apparently achieved low Earth orbit, and it's a piece of cake because there's supposed to be all these satellites up there, the International Space Station and everything else. But when it comes to getting civilians into space, they just can't seem to do it. I think that's very surprising.
Well, let me jump in here for a second. I mean, I didn't have a lot of time to kind of educate myself up to your level before we did this, because we just decided last night we had time. But I did glance at the Virgin Galactic record, and I think what you're pointing out is a fingerprint of fraud. But they're not even really talking about low Earth orbit as the first part of what they said they were going to do. They're talking about going up to the edge of space and falling back in, aren't they?
Yeah, I think so. I mean, really, once you cross into the thermosphere, you're technically in space, or the thermo layer, whatever you want to call it. So, yeah, I'd have to look back at their stuff. But I mean, basically all of their flights have had some type of malfunction, and they haven't been able to even really get up there, from what I've seen.
What I read was, I think their Wikipedia entry, which I'm sure they have their fingers in, talked about, I think, 60 miles, something like 100 kilometers.
Yeah, 100 kilometers is or like right around 100 kilometers is the border of the thermosphere. So yeah, that's what they're once you cross into the thermosphere, technically you're supposed to be in space. So yeah, that should be no problem in 2000s, late 90s, but apparently it is.
I mean, we're seeing amateur rockets claim 73 miles recently.
Yeah.
So here's Virgin Galactic with all these investors and all this help from supposed NASA experts, and they can't even do 60 miles. I mean, because they're not talking about, I believe, I hope I don't have this wrong, initially, if I'm right, they're not talking about poking out into what we call space and dropping into orbit. They're talking about going straight up to the edge of space and then falling back in.
Well, yeah, but their spacecraft is like it's a plane. If you've seen it, it piggybacks on the back of a commercial airliner, right. And then it launches off of that. And so they try to get into an orbit to just get up into space, because you're supposed to have to achieve an escape velocity before you can get out of Earth's gravity,
right?
To be able to get into that area of space. So I think their idea is to get into orbit, so just barely get into orbit, so you can achieve that weightlessness. And so they since they're using a plane type of spacecraft, that could be argued that they're not using the conventional means of launching from a ground pad, and that's why they can't do it. But I think it's very suspicious that we don't have civilians in space, and they claim on their website that less than 600 people have been to space ever, and I mean that's very few people. So.
It's almost ridiculous because I follow some channels who have demonstrated to my satisfaction. Of course, most people are aware that I make the statement no one has ever gone above low Earth, or what we call low Earth orbit, and that there seems to be a hard, fast barrier of some sort there. But some of the people I was following were showing that the images that were being handed off as space satellite images or ISS images of Earth could actually easily have been shot with high altitude planes. And excuse me, while it's not clear from the video alone exactly how high those planes are, it's pretty clear that they're way the heck up there. So when we consider that Virgin Galactic's got this kind of plane type spaceship, for lack of a better word, there's already planes that are doing super high altitude flights, right?
Yes, yep. I mean, there was definitely aerial photography going on before any space travel, so that could very well be where these pictures are coming from. So, yeah, that is the theory, if that's what these pictures really are.
Well, before I kind of pulled you out, you were going on Virgin Galactic. I'll hand it back over to you so you can keep going down the line of reasoning you were on before I kind of wanted to just frame it for people so they understand what we're talking about.
Mm. Oh, and well, one thing I also wanted to point out is if NASA went to the moon in 1969, to really think about going to the moon is such a huge feat compared to going into low Earth orbit, and to think that they did that almost 50 years ago and Virgin Galactic can't just get into space. I mean, there's something seriously wrong here. That's another thing I wanted to point out on that.
Well, there's no doubt, Brian, and here's the thing. What we always see is the fingerprint of violence, tragedy, these types of things. When we see what I consider to be a hoax, and I don't want to put words in your mouth, for me, Virgin Galactic is a complete fraud. But I don't want the listeners to get the impression that that is your view. That is my view. My point would be, is it is so typical that we see these grand statements made, and then when they're not achieved, of course, there's an exploding rocket, or somebody gets killed, or all these events that I consider to be hoax events. But anyhow, I'll shut up now. I'll hand it back over. Go ahead down the road with the Virgin Galactic.
Yeah, I mean it's really tough to say. I mean, I don't like saying that things are hoaxes, but I have my suspicions that I mean, they blow up. It makes space seem terrifying. I mean, everybody sees these things, all these accidents they have, so nobody's going to want to fly on those spacecraft, even if they successfully get one up there. I mean, all the other crashes they've had. It's just, I mean, who wants to do that? Who wants to pay a couple $100,000 for a ticket and then risk losing their life?
Good point.
You know, and but then you also have, SpaceX supposedly has no problem getting into space, but they only work with NASA and they only deliver payloads to NASA's alleged vehicles in space, or the ISS or whatever up there, and so that seems to not be a problem. But when it comes to getting civilians up there, it doesn't happen.
And SpaceX had their dang explosions kind of in line with the timeline of Branson's company, Virgin Galactic, not making it to space.
Mm-hmm. Yeah, yes, they did. And it's, I don't know, I think, I mean, people are scared of the idea of going into space, I think. But with all the money we spend, we pay for all this. I mean, when you really think about it, we should own. I mean, we do own NASA. We should own all these space agencies all over the world. The people of this world should own these agencies, and they're not making any effort to get us up there to see what's going on. And so it's just very, very suspicious. And then going back to the moon landings, which when I was in college, I kind of thought to myself, well, how come we haven't gone back to the moon? And I started looking into it, and to be honest, I don't believe we went to the moon. And there's a lot of people that agree with me on that. I know that. So But if you assume that we did, and then they can't get into space, it goes back to reiterate my point that it's just this should not be a problem to get civilians into space on commercial flights at all. And in 2016, it should already have happened.
There's no doubt. I mean, there's a site, and when we're done with this, I'll kick you a URL to a gentleman who was at one of the Ukrainian universities. He's a PhD. He runs a site he posts on a site called Aulis.com, where he used parallax method, provides the formulas, and he demonstrates that I don't even know how many Apollo images he took apart to demonstrate that the mountains they're claiming are 5 clicks behind them are only, they're on a soundstage basically. But I'll kick that to you. Go ahead.
Okay, great. Yeah, I've seen a lot of that stuff, and but yeah, it's very hard to believe we went to the moon. And then when you really start to think about satellites and GPS, I mean that's the first thing. If you start to question what our world is, and you say, well, we have pictures of the world, I mean, the first thing I thought about was satellites and GPS. And then if you do some research on the GPS system, or the global positioning system, as it's called, you find out that it actually was developed during World War II and went into service in, I think, 1947. And there were no satellites then, so they were using relay towers. And so it definitely worked before there were any satellites. So you could say that maybe it still works off of towers if there are no satellites. And so when you really start thinking about the satellites and you start studying the thermosphere, I made a couple of videos about this. The temperature in the thermosphere is supposed to be around 2,000 degrees Celsius, gets upwards of 2,000 degrees Celsius, and that's the temperature is a measure of basically the kinetic energy in a substance, and so there's supposed to be very few molecules, atoms, very very little matter up in the thermosphere, and so the temperature is really hot, but they tell us that everything is all the particles of matter are so far apart that you can't actually put a thermometer up there and measure the temperature, so it would actually show a very low temperature. So it gets really confusing. Well, what's the temperature up there? And they say that the particles colliding with let me back up. The ISS satellites and all of these objects are supposed to be in the thermosphere layer of the atmosphere. The majority of these satellites are supposed to be in what's called low Earth orbit in the thermosphere layer, which extends to, I think, from about 100 kilometers to about 500 or 600 kilometers. And so that area is where the bulk of all this stuff is, and that's where it's really, really hot. But it's also really, really cold. So it's kind of like doublespeak when you really start thinking about it. And when these objects are in direct sunlight, they should get very, very hot. And then when they go onto the dark side of the Earth, they should cool down rapidly. And the ISS has all these cooling systems that they tell us about. They use liquid ammonia and I mean, this really high-tech stuff. It's kind of works like a radiator. But then when you think about that, what about all the satellites that they've been launching since the 50s to 60s, or not? Well, maybe the late 60s. These things didn't have that technology back then, and we're talking 2,000 degrees Celsius. The temperature up there. If any of those vehicles reached that temperature, I mean, we've got plastic, gold, copper, aluminum. All of these things melt at much lower temperatures.
Well, wait a minute, Brian. So, I mean, correct me if I'm wrong. That's about 3,600 degrees Fahrenheit. Is that right?
Yeah. It's really, really hot.
But I think the melting point of glass is just over 2,000 degrees Fahrenheit, right?
Yes, yep. And the melting point of aluminum is 660 degrees Celsius. And I'm constantly thinking in Celsius, but and then if you're at 2,000 degrees Celsius, I mean, you're definitely going to have aluminum on anything you launch into space because you want it to be light to get it up there.
Right.
And so that's what's the how does that work?
Is there any substance that you're aware of that won't burn or melt at 3,632 degrees Fahrenheit?
Well, I know tungsten has the highest melting point of metals, but it's also very, very heavy, and so I'm sure they don't have any tungsten on these vehicles. So it's I don't know. It's kind of it's hard to accept the explanations for it, I think. And everything's supposed to heat and cool quickly because of thermal radiation, but then how does thermal radiation work when you don't have any matter to transfer the heat into? It's kind of like there's this jump from matter to nothingness. I mean, I'm kind of getting a little away from the satellites and everything, but the sunlight is supposed to travel through space and hit the Earth, and it travels through electromagnetic radiation, which doesn't need matter to travel through, as we're told. But when you radiate heat away on Earth, if you're driving your car in the middle of August or in the middle of the summer, the hottest month, wherever you are, and your cooling system isn't working very well, it's more likely to overheat in the summer than it is in the wintertime, because the ambient temperature around your engine, doesn't allow heat to radiate away from the engine, and then your cooling system and everything as fast as it would in colder temperatures. I mean, it's kind of common sense, and so we've got these really hot temperatures all around these satellites, and the heat just immediately radiates away from it into nothingness. But on Earth, when these temperatures vary, it has an enormous effect on how well heat can radiate away from something, if that makes sense.
Right, but I mean, down here, I'm assuming there's a lot more particles in what we call the air than there is up there. Does that play a role in being to, ditch some heat off the surface of anything?
Yeah, that's the idea, is that when there's not, that heat becomes infrared radiation. And so when you use like an IR thermometer, if you've ever used one of those, or a FLIR camera, those measure infrared radiation, but the infrared radiation it's measuring, I mean, those waves are traveling through the matter, what's in the air, and so I'm assuming that's what it's picking up, or that's what I say it's picking up. And so in space there's nothing, so it's almost like everything should just radiate away instantly, based on the black body theories. And getting into this without having like a piece of paper or something to show it is kind of hard to explain, but I made a couple videos about this. And basically, there's the assumption that there's this infinitely cool black bodies in space, and so heat just immediately radiates away from everything. And so what they could say is that one side of these satellites heats up, and then the other side is radiating. Like if a side of the satellite is facing the sun, then the opposite side is radiating the heat away instantly into infinitely cold space, because hot goes to cold. I should have said that earlier. I mean, that's the basic thermodynamics, is like areas of higher energy or heat go to areas of colder energy. It doesn't go the other way. It's a one-way street. So basically, there's this infinitely cold outer space out there that the heat can escape from these satellites. But why don't the astronauts freeze? I mean, that's another thing. I mean, we've got to keep them. We've got to have heating systems. We have HVAC systems that keep the astronauts at a comfortable temperature, and they've got this infinitely cold space around them. How is an HVAC system going to work with no matter? It's very. I mean, you can look into it. There are explanations for these, but just because there's explanations doesn't mean that these things are actually true.
Well, one thing that stumbles me, listening, what was it? The thermosphere? Is that what we were talking about? Okay.
Yeah, that's what I'm focused on right now, because
okay.
That's where the really high temperatures are supposed to be.
So, you get up there and it's roughly 3,632 degrees Fahrenheit. Every one of these rockets, the boosters that get anything up into supposed space, has combustion engines, which means it's burning fuel. So how in the heck do they contain any fuel through temperatures like that without having it explode?
Yeah, the explanation for that would be that the particles are so far apart that there's so few particles of air up there, or gas, whatever you want to call it, that they don't transfer the heat to the space shuttle or whatever, because there's not that many collisions, because you have to have matter touching matter, basically, or colliding with other matter to transfer heat. I mean, it basically has to be touching it. So they say it's really, really cold, and that's the thing. You can't measure the temperature, but we know it's 2,000 degrees. So how did you measure the temperature in the first place? It's a lot of circular questioning, I think.
So it's 3,000 degrees, but the particles are so sparse up there you could stand still right in the middle of it and never burn up.
Yeah, exactly. But
of course.
Mm-hmm. And then then the particles are being heated by the sun. I mean, obviously, what else would be heating them? And the thing is, hot goes to cold. And if you think about it, the thermosphere is surrounded by space, which would be infinite cold. So the heat, I mean, the higher your temperature differentials, the colder something is and the hotter something is, the faster heat travels from that hot source to the cold source. Like the bigger the difference in temperature. So if it's surrounded by infinitely cold space, when the sun is not facing that side of the earth, then that side of the dark side of the earth would want to cool. I mean, like almost instantly. The air and everything would want to cool instantly. And so then you've got all these satellites and everything that are up there in the thermosphere with this air that's heated by the sun. How come they aren't subject to that same enormous heating and cooling? It doesn't make a lot of sense. They tell us that the temperature swings aren't as big as what the temperature swings for the satellites aren't as big as what they are for the air that's up there. But I don't understand how that could be, because denser steel, I mean, not steel, but aluminum metals, plastics, things like that, they're going to absorb even more heat than sparse air particles, if that makes sense. So.
Yeah, satellites are a funny thing, Brian. I don't know, 4 or 5 years ago, I was still giving satellites the benefit of the doubt, maybe as short as 3 years ago. I had filmed some things that, for a long time I'd been filming, and I'd tried to film satellites. I would look at when they were supposed to be transiting the moon. Couldn't do it. Finally got a couple that I thought were possible, and at the time I just took NASA's word for it, or whoever lists the satellites, and said these are likely satellites. But come to find out, and people who follow me, I have stated that satellites do not exist in the way they have been described to us. But, actually, I've further said that the hardest thing you can ever try to film is a satellite that you can identify transiting the moon, which is really the only way you could film one. You need that backlighting to get any kind of a shape. But what I have filmed is a ton of these little black round things. But I called an optical expert at the scope shop when I was still in San Diego to calculate my system, my scope, my camera, to calculate what the physical distance in feet of a pixel would be at certain distances away from me, and concluded that everything I have filmed is much closer than satellites should be. Where are you at? I mean, do you believe that we have, whatever they're claiming, 10 to 20,000 satellites out in space?
To be honest, at the moment, I don't. I mean, that's besides all the temperature problems. I've done a couple of videos on, even being able to propel yourself in space. And in the 1920s, the New York Times actually wrote an article basically making fun of a doctor who was claiming that propulsion would be possible in space because there's no reaction to the thrust. And then after the moon landing, they redacted what they had said, apparently. But when you take in propulsion and these temperature changes, like I don't think it's possible. It defies logic. I think it defies physics.
Well, I mean, that brings us around to the ISS, and this is one of the most baffling things. I have proven to myself, beyond the shadow of a doubt, that the ISS is complete fraud. That the videos we see are stagecraft, but that does not remove the fact that there is a light up there that follows a schedule that is often exactly where it should be, and images have been taken, and it's very difficult to shoot because we're told it's traveling 17,000 miles an hour or whatever. It's supposed to be very fast, but it's roughly the shape you would expect this light. But, I mean, the ISS is no different than the satellites we're talking about, and as a matter of fact, it's probably even in worse situation when we begin to reason things out just because of its size.
Mm-hmm. Yeah, it's supposed to be rolling about 400 kilometers up, I think. And, I know they tell us that it has an ion thruster on it that they have to fire every like 6 months or so because of collisions with the air particles that are up there that aren't hot enough. That there aren't enough collisions to transfer all that enormous amount of heat to the station, but there's enough collisions to slow it down. So it's got to fire this thruster to get it back up to the velocity, because you need a certain velocity. Based on the heliocentric model, you need a certain velocity to stay in orbit and not get pulled back down towards Earth. And the ISS, I've seen a lot of the videos that show that make it look like it's fake. And when you start adding all this the problems with physics, I think propulsion and temperature, it's when you put the two together, it really doesn't seem like it's there. But as you said, I mean, my dad has seen he's gone out to see it early in the morning to see whatever it is that's up there. There's definitely something there.
There is a light, yeah.
Yeah, there's something up there, but is it what we're told? I really have my doubts about that. And I'm glad you pointed out that you've tried to see this, because I haven't had time to go out and try to find this stuff myself. But I've seen a lot of other people are doing that, and that's great.
Well, I'll tell you something that is a very kind of fingerprinty telling thing about so many of the things we're lied to about. I started to see a lot of footage of people claiming that they had the ISS transiting the moon, and here's the perfect shape that you would expect, and it's white. Well, I've filmed the moon for many thousands of hours, and I can tell you unequivocally, anything you film between your lens and the moon is going to be black unless it is very well lit, and then it's just going to look like a point of light, but it would have to be much brighter than the moon, which is not that easy. You know, the moon's pretty bright. The point I would make is I have a lot of experience with telescopes and cameras with telescopes using them. It is so damn difficult to get a still shot of that object, because I've tried. And I have actually got it in frame a couple times, but what I got was a smear because I didn't have my frame rate and everything else for the still shot to be perfect. And I wanted a still because the resolution is higher on a still than it is on video for my cameras, and you can zoom in better. The point I would make is I do have some trusted friends who I know would tell me the truth, and they have a couple of them clicked off images. Some of them have taken high-speed video and pulled a frame, which may be the best way to do that. And there is an object there that does kind of have the shape that we expect. But there is no doubt that every bit of footage we've been shown from astronauts up there, or all the reasoning we can do, demonstrate that it's just not possible what's been described to us.
Mm-hmm. Yeah, that's what I wonder. Is there something up there that's not manned? I mean, that's those are the questions that have gone through my head. But like you said, with the astronauts, they don't. From the video I've watched, I've watched a lot of hours of just astronauts being on the alleged space station, and they seem so limited. They're just, I would, just thinking about being up there, how awesome it would be to be in space. I mean, you just would show off more. You would I would just expect to see a lot more of the station and outer space, like look out into outer space and not just down at the Earth. I don't think what's up there is what we've been told, but there's definitely, like you said, it seems like there is something there. You know, but what is it?
Yeah, exactly. It's a light, and when you begin to accept that you know for a fact there is a light there, you know, my name's Crow. I've shot for thousands of hours. I've looked at the sky since '94 or '95. Regularly, there is a light there. I can assure you there is a light there. And if you look up schedules for the ISS, that light often coincides. And I have seen pictures which demonstrate it's close to the shape you would expect. But if you use your God-given ability to reason out things like, can you imagine what it would smell like inside that
place? Yeah, all the dead skin floating all over the place, not being able to take a shower for being up there for a year. I mean, that would be miserable.
Well, I mean, how could you get anything done? I mean, if you would equate it with maybe a porta potty that was used by however many astronauts there are for, say, 2 years and never cleaned. Could you work in there? Could you work in that environment?
Yeah, that's that's really hard to believe that they can stay up there that long and look as good as they do in the videos.
Well, it gets better. I mean, there's plenty of, there was videos early on that said, oh, we have to be so careful with water. And then I did a video not too long ago where it shows one of the female astronauts washing her hair, and she's flinging water all over that place. And the further you get in, you can begin to see the ridiculousness of it. And, I've said for a long time, belief is the enemy of knowing. This is exactly why I say that. Because if you can set aside believing that what you're being shown is true, then reason sets in and you can begin to really get down to it. But let's pull back over to satellites for a minute. And there's another thing, Brian. I mean, wouldn't you imagine of the 10 or 20,000 supposed satellites that some astronaut might poke a camera out the window and show us one of these amazing things in space doing what it does? I'll state unequivocally, there is no real video or imagery of a satellite in space that I am aware of. So let's take apart satellites a little bit here and see, let's get your point of view on where you've come using hard, cold science.
Yeah, that was a huge thing for me. Where is a real picture of a satellite? Why, when they're doing these spacewalks, don't we ever see a satellite go whizzing by? There's supposed to be thousands of them up there. And then another thing to think about is just all the space junk that's supposed to be up there. A friend of mine who also does some videos, a guy named Droid Fuel on YouTube, he's done a whole video on the thermosphere and the space junk that's up there. And when you calculate the energy in just an object the size of like a dime, I mean, it would if it hit a satellite or the ISS or anything, I mean, it would be like a truck hitting it at 60 miles an hour. I mean, it would just destroy anything. So to think about these satellites and the astronauts all up there, the ISS is a death trap. I mean, because at any moment they could be hit by debris that's not being tracked because NASA can't track all of the debris. And then all these satellites would be subject to being hit by this debris that's up there as well. So it's really hard to believe that they're up there. Like you said, we don't have any images. They're all CGI when you really start to look at them. And so combining that with the temperature swings and propulsion and the debris, it's just, I don't think they're there.
Well, I actually made up a law that I wanted to add to my research, which is pretty simple. In the digital age, anything amazing that can be filmed in high definition will be filmed in high definition.
Definitely.
And so there it is. And then, we see things like the movie Gravity where, the dangerous micrometeorites. But here's another thing, I can't tell you how many years, hours, or anything I've spent outside looking up at the night sky. And in that time, I've seen probably many hundreds of fireballs that we are told are meteorites, which, by the way, I do not accept. But if for the sake of this conversation, I will accept that those little fiery things that we see in the night sky are meteorites, a lot of them look like they may have hit the ground somewhere. And I've seen tons of them. Even on nights where there's supposed to be a meteor shower, you see lots of them, sometimes more than 100 in a single night. But watching the moon, it is exactly the same the first time I ever looked at it through a telescope. Nothing has changed. Nothing has hit it. Nothing has moved in all this time. And, talk about laws. One law we know for a fact is correct is change. That is not a rule. That is a law. Change happens nonstop. And yet the moon seems to be immune to it. So when we think about satellites, I mean, one of the big things they were pushing was the danger of micrometeorites, which was echoed in the movie Gravity.
Yeah, I haven't seen Gravity. I've been wanting to, but that's interesting that they do talk about that.
Well, it rips everything apart, and I've always wondered if guys like you and me rip this apart enough. Is that what we're going to see? Is the big ISS disaster?
Yeah, I don't know. That would be crazy. I mean, to think it's been up there since 2001, and they've been able to avoid all of these collisions is just it's very hard for me to believe that they can maneuver that thing so well to be able to avoid all of this debris that's supposed to be up there and all the other satellites that are up there. I mean, every now and then we have a satellite crash to Earth, but I would think it would happen all the time. It's just, it's very, very hard to believe for me.
It's beyond the pale. And before, I'm going to jump us forward here into propulsion in space, but before we leave this behind, since we started with Virgin Galactic, I'll throw it out to all the listeners. Last night, when I finally confirmed with Brian that we would do this recording this morning, he had listed Virgin Galactic as one of the things he'd like to cover. So I jumped on Google Earth and went and looked at the Virgin Galactic spaceport in New Mexico. Let me tell you something. I didn't have a lot of time to dissect it, but every hoax that we see in the modern age will die under the weight of its own details. I invite all the people listening to this, go to Google Earth and dissect and Sherlock Holmes to death the imagery they're giving us to the spaceport. Because to my eye, for the 4 or 5 minutes I had to look at it, two things stuck out. Where the Google Street View ends, it looks like a cattle ranch road, but the real thing that killed me is all around the spaceport, it looks like nobody's driving. There's a couple lots there with mud, but anyhow, I invite people to go rip that apart and post what they find. Use your God-given ability to reason logically and see what you come up with. It'll be interesting to see. But Brian, let's jump forward to space propulsion, and I noticed you mentioned the ISS is claiming ionic propulsion. Do you accept any of it? Do you accept the ability to have propulsion in space in the way it's been described?
Yeah, that's when it comes to a monopropellant. I did a few videos on this, and basically a monopropellant is some type of gas that's ejected from a pressurized chamber out into space, and it's when you think about on Earth something moving in the atmosphere, when you blow up a balloon and you blow up a balloon and you let go of it, it flies around the room. The air is coming out of the back of the balloon, and the reaction between the thrust leaving the balloon and basically the opposite reaction pushing on the balloon is what propels it forward. And so that action reaction or conservation of momentum is what it really is when you get into it, is what's supposed to propel things in space. Just the idea of forcing matter or letting matter, ejecting matter out into space pushes the object forward. But with that balloon on Earth, you have atmospheric pressure. So when the air is leaving the back of the balloon, the atmosphere or the air is pushing back on the thrust that's coming out of the balloon. And the same thing with the jet engine. When the jet engine's pulling air into the intake and then nozzling it down and forcing it out of the back of the jet, there is air pressure pushing on that thrust. I mean, basically forming it into the shape of thrust that you would imagine. And so when you go into space, you don't have that at all. You have no pressure at all. I mean, basically zero pressure. So there's nothing pushing back on that propellant as it's leaving the nozzle or the pressurized canister or chamber. So to be able to move up there, you would think that when the monopropellant leaves the nozzle, it would just expand infinitely because there's nothing pushing back onto it. Because in space, everything, as we've always been taught our whole lives, everything just expands, and that's why we have to wear a spacesuit so your body doesn't expand infinitely and you basically explode. Because on Earth there is 14.7 pounds per square inch of pressure roughly at sea level holding your body together. So if you go in a vacuum chamber, you would explode. So to think that a monopropellant could work in space is very hard for me to believe, and it's kind of hard to explain this without having a board in front of me. But I know what they use. Basically, the conservation of momentum is Newton's third law, which says every action has an equal and opposite reaction, and it's just a different way to write that equation. And so the way it's taught, when I really started to get into this, it's funny, a friend of mine was taking basically like a rocket science class. MIT offers free courses that you can take, and He said that in the course, the professor stands on a skateboard and throws some weights away from him. He pushes the weights away from him, and he moves one way and the weights moves the other way, and that's their explanation for how a monopropellant works in space. But I say that's not the same thing, because what you're doing is you have two masses with an action happening between them, forcing them away from each other, whereas with a monopropellant, the monopropellant is already pressurized in a tank, and so you're just releasing it into infinite outer space with no pressure pushing back on it. So the action reaction's already occurred before you release it. So this is hard to explain with just words, but
I'm following you.
Okay, so it's kind of like a bullet too. Like if you had bullets, I think you could move in space. If you took a whole bunch of bullets up into space with you, and you had them you had barrels sticking out of the whatever spacecraft in all direction, and you created an explosion between the bullet and, of course, the casing of the bullet, which is lodged in the chamber and then stuck in the spacecraft, then you would be able to move because you would force those two masses apart. But to just release compressed gas into space is not the same thing. So the gas would just expand infinitely just based on pure logic. There's nothing pushing back. You would need another mass to be forced away from the spacecraft. To force the two masses away from each other, and so that you think about it, that would be incredibly inefficient. You couldn't do that. You couldn't carry all that ammo up there, or whatever you want to call it, all these little charges to be able to move. And you would only have a set amount of charges, and once you run out, you can't maneuver anymore. It really doesn't make a lot of sense. And then when you go back in history and look at how everyone was saying, that this defies Newton's third law, space travel is not going to be possible. That New York Times article I pointed out earlier, it's almost like it was common sense that it wouldn't work, and then suddenly they'd go to space and prove everyone wrong and prove that it's just conservation of momentum, which basically says the action reaction between the monopropellant and the spacecraft is all you need, and you don't need subsequent action reactions like we have on Earth, where basically there's always something pushing back, and so down the line you have a continuous load path, if that makes sense.
Well, let me ask you, I think a lot of people are probably familiar with a certain clip where a gentleman made a little car that was propelled by an inflated balloon, then he used a vacuum to demonstrate that it doesn't work. Is there any validity to that example that he did?
Yeah, I think that's a perfect example, though people try to argue and say that there's other factors in play. But what the conservation of momentum says, which is derived from Newton's third law, says that at the back of that balloon, I've seen that video, at the back of the balloon, where between the reaction between the air leaving the balloon and the reaction of the car pushing back on the balloon is all you need. So whatever happens to the thrust beyond that point doesn't matter. This is what it's based on. Conservation of momentum says that only that the action reaction at that point is what matters, and it'll move if you have an action reaction there. And so if the thrust is being sucked into a vacuum, it should not matter, because that's basically simulating an infinitely expanding space. And so the car should move whether the vacuum is there or not. And obviously he proved that that's not the case. And some people have said, well, it's creating, an area of low or high pressure in front of the car or something, and that's what's not letting it move. But I don't buy that. If these things could really move efficiently in space, and these little jets of oxygen that they used to use on the space shuttle and everything can really direct movement, then we shouldn't see hardly any effect on that car if conservation of momentum is true and only that action reaction matters. So I think that's a good experiment. I've been wanting to do one myself, but I've been a little wrapped up with getting married and things.
Yeah, so. Definitely. That begs the question, Brian, is a test like that sufficient to make a strong case, or is it going to be another one of those things where there's enough ambiguity in some portion of what's being done that it can just be, argued ad nauseum?
I think it is. That's my opinion. People are going to disagree with me because, when you go back to it, what conservation of momentum says is that only the action and reaction between the exhaust and the spaceship, or the exhaust or the thrust and the spaceship, or the thrust and the car is what matters. That's what they tell us. That's all that matters. So if that's the case, then whatever happens to the thrust after that reaction has occurred should not affect the movement of the car or the spacecraft. And so because he's vacuuming that thrust away, it should not affect it. It should still move. And obviously it stops it. So,
well, if you did a clip like that, I would tune in for sure. I would be very interested to see that. In my view, just to jump off topic here for a second, you represent, in my mind, kind of the new vanguard of human beings, for lack of a better description. People like me, I've never had a problem with challenging what I viewed, but to be honest, it's been very few times in my life where I've had like a whole science-based job where there's protocols that require me to, walk the line to get a paycheck. You are a guy who's working in science, who's well-versed in science, but has come to a point where you're prepared to question. And I think very few people in such strict adherence fields have been willing to do that to date. But I wanted to ask you, I've kind of come to the wholesale conclusion that science in the Western method, has handed us through Einstein, anyone, Newton, Galileo, is basically the foundation of that is materialism. Do you think that's a fair statement?
I've never thought about it that way, but I think that is a very good point. I mean, materialism is a huge issue, I think, with our society.
Right.
And that's something I'll have to think about. But that is a very good point. I mean, we're so focused on the material world and everything. Everything we desire, that science has kind of evolved around that.
I would even take that a step further. I'd like to get back to you when you've had time to kind of parse that. But in my view, science as we have been handed it in the West, its foundation is materialism. But to take that a step further, I would say, having thought about this for quite some time now, that as an example, what Einstein handed us, while valuable in its own way, I guess, although I'm not sure there was ever a man named Einstein, to be honest with you, what it did was basically killed spirituality and the possibility of, it's a lack of terms here. I don't want to say religion. I really don't want to say spirituality, but I think people understand where I'm going with this. Where I'm going is that if we are completely anchored to a material world, in my view, we're handicapped. We're never going to get as far as we could. We're never going to figure out some very important things. And I think people like Einstein basically lopped off anything beyond materialism. Do you think there's any there?
Oh yeah, definitely. I'm consider myself a spiritual person. I definitely do believe in a creator, and when we just focus on this material world and think that this is all there is, in science, the idea of anything spiritual, or if you say the word God, it's a bad word. You can't say that. So science is based. I really like where you're going with this. Science is based only on the material world. You can never go beyond that. So the material world has to explain everything, and so from that, we can never take an explanation from anything beyond the material world. That really does limit us. And so, yeah, like I said, this is one I have to think about for a while, but I've never thought about it that way. But yeah, I do. I think it definitely takes away any sense of there being something more, of there being a spirit. For one, an infinitely expanding universe all around us, and to think that the Earth is just a speck in a universe that's just unfathomable size, makes you feel like nothing. It makes you feel like there's nothing important about this world, and I personally think that that's not true, and that we are significant, and if science has led us away from that, well, that is that is a serious problem.
Well, let me come at that. I recently had a guest who described exactly what you're talking about as well as I've ever heard it described. If we, let me put it this way. When I was all the way back in a junior college, I've been back to school so many times in my life, but at a junior college course that I once took because I was interested in astronomy, in the very beginning of the astronomy book is this whole layout to show you how the distances involved are unfathomable. You can't wrap your head around them. The distances are just too great. And the guest I recently spoke with pointed out that if you accept the distance of the sun, 93 million miles, whatever it is, the moon, 250,000 miles, whatever it is, the nearest star, so many hundreds of thousands of light years, you cannot get your head around these things, and the result of that is you have no place in it. But if these things are incorrect, and the sun and moon are much closer than we've been told, even the shape of this planet is not correct, then all of a sudden...
I'm sorry.
It's all right. Don't worry about it. I've got my own dog problems. I'll give them a minute to calm down. Don't worry.
Yeah, let me let them in real quick.
Yeah.
All right. Yeah, he does that.
No worries. In a minute here, I'm going to have to take a break to get my dog out. But what I was about to say is if we don't accept these grand, unknowable distances, and we choose to look at the idea that the sun's much closer, the moon's much closer, what it does is it allows you to actually be a part of that. All of a sudden, you can find your place. You can get your head around it. And it almost seems like a lot of these unknowable distances and these grand illusions, their main purpose is to remove your ability to place yourself in the equation anywhere. All right, that's the end of the free hour of episode 14. I will reiterate because there was some building and pounding going on, as I said it at the front of this clip. We cover a lot of ground in the second hour, which you can catch on Crrow777radio.com. The main thing that stands out, or one of the big things that stands out in the second hour, is Brian is planning to build a monument of sorts that is miles long, designed to demonstrate that the curvature of the Earth we've been told is there, or to determine it is not there. The great thing about this is it's going to be built in a way where it is near a road for access, this kind of thing, so people can go see it, but it's going to stand almost like a very big statue to show the measurement that's been done. And bear in mind, this man's an engineer, a structural engineer. So there it is. I hope to see you all over at Crrow777radio.com. Cheers.